So we'll start off with the midterm review constructions page, and then I will go into the angle measure page, and that will be the first video for the first review day. So in number one, it already has the construction drawn for you. Somebody put the compass point here and drew an arc, and then from these two places here, they made these two arcs. It connected from the vertex through that intersection, and what that does is it divides the big angle into two congruent bisected angles. So based on that, which one of these statements is true? We know that this angle is equal to this angle, so that's ABD and CBD, and that's actually what choice B says right there. So you have to go through each one and see which one makes sense. Number two, this one asks you to do exactly what number one said on your own. So you put the compass here, you make any arc you want, and then wherever the arc hit each ray, where the purple spots are, you put your compass here, and you make an arc out here. You put the compass here, and make the arc out there, and then you bisect from the vertex right through the intersection, and now you have bisected angle ABC, which means that is equal to that. Number three, a perpendicular line through a point. If it was just a segment, you would take the compass on each end and go more than half, more than half. But it's a line and it has to go through P. So the first thing you do is make your own endpoints. So you put the compass on P and you do the smiley face. What that does is it gives you the segment endpoints where P is centered right in the middle. So then you do more than half, more than half. And what you'll end up with is a line through P. I'm going to do that a little neater. I'm trying to do it without a compass, so I'm off by a little bit. You would go more than half, more than half. And when you draw the line, it will go through P. It'll be perpendicular. It'll break the segments up into two congruent parts, but this was a line and it goes through P. Number four, we did this one in class, but to construct, an inscribed square. First thing you want to do is just use your straight edge, go through the middle and create a diameter. This is the diameter's endpoint, and this is the other diameter's endpoint. From one of the endpoints, you go more than half. From the other endpoint, you go more than half. And then you bisect the original diameter. And what that does is, it will make a 90-degree angle there, which means, as you'll learn later in the year, that's a 90-degree arc. But more importantly, you now have two more places on the circle that are all 90 degrees apart, which creates a crooked square. 90 degrees in the corners, and all four sides are the same. An equilateral triangle is the same as a hexagon. You draw yourself a radius with your straight edge, then you put the compass, the metal point there, and the pencil here, and make yourself an arc upward like that. Then you put the metal part right here, and keeping the compass the same distance, you make an arc here. And then you chase it all the way around the circle until you have a total of 6 equidistant arcs around the circle. If you used all 6 and connected them, you would have a hexagon. But you have an equilateral triangle situation, so you just pick any or every other one to make 3. Any 3 that are 1 apart. Doesn't have to be a specific 3, as long as they skip every other one, and you will then have an equilateral triangle. Number 6. Construct a line that's twice as big as CD. This is probably the simplest one on here because we just did it with dilations too. Measure this first by putting your point at C and open up to D. And remember, make this arc to prove that you were there right there. Carry over to this point, copy it once, copy it twice. And it wants B right there. twice the length. Number 7, which statement is false? Well, we know this was a bisector construction, just like numbers 1 and 2 on the first page. So we know that that's the same as that. We know that angle ABD is congruent to CBD. ABD is congruent to DBC. But that's true, and it wants to know which one is false. So that's not the answer. Half of ABC is congruent to ABD. Let's check that one. That's ABC. Half of that is congruent to ABD. So that is true, which means that's not the answer. Then it says 2 DBCs equal an ABC. There's a DBC. There's an ABC. No, that's true too, because 2 of the small ones do equal the big one. So it looks like we're headed toward choice D. Let's read it. 2 ABCs equal a CBD. No way does 2 of those equal anything there, because that's already the big one. So that's the one that's false. Take time to go through each multiple choice and see which one makes sense and which one doesn't. Some people like multiple choice, and some people rather have short answer they can show their work. But in either case, you're going to have a majority of multiple choice on the midterm and on the regions. So make sure to go through each choice and test them all. Number 8, equilateral triangle. This is not my favorite question because of the way the choices are written. There's more than one true thing, but it has to do with the way the question's written. Which statement justifies the construction? Well, this is an equilateral triangle, so it is true that all 3 angles add up to 180. But that's not how we made the construction. It is true that angle A, angle B, and angle C are equal because it's an equilateral, they're all 60, so that's also true. But what we really did was copied segment BA by making an arc the length of AB in that direction, and then making another arc. You're not seeing it here, but that's part of it there. So what we really did was copy that segment 2 more times, which made all 3 sides the same. If you understand the equilateral triangle construction, don't get hung up on the choices on this one. This was generated from a Regents bank of questions. I don't like the choices. Don't get hung up on this one, as long as you understand how to do the equilateral triangle construction. Number 9, which is not always true. As you can see here, we have the fish, the more than half bisector construction. So we know that you're going to have a 90-degree angle here. So this is always true, so that can't be it. They will always be perpendicular. Let's go down to choice C. AE will always equal EB, so that is always true, so that's not it. AB, though, and CD. AB and CD, those 2 distances, have nothing to do with one another. They'll be bisected, but they don't have to be the same size. One could be far longer than the other. So that's the one that isn't true. The last one, CE and DE, those will be bisected as well. That distance, the top half of the fish and the bottom, will be the same as each other. So that is always true. But AB and CD are not necessarily always the same length. In fact, rarely will be. Then it has you just go ahead and do it on your own here. Bisect this segment. Put the compass here, more than half. Put the compass here, more than half. Go right down the middle. And what you've done is created a perpendicular, in this case, bisector. Now, because I'm already at 9.5 minutes, I'm going to cut this video off here, and I will upload the angles as a separate video today.